Yeah, so where was I with this? Oh yeah, so just had to take a call. They're gonna sell my little heaters. Some guy's gonna buy both of them, so that'll be good. So just get rid of them. So anyways, after we get this this epoxy sets up on them, and these discs are going to be tied to the wooden blocks, I'm going to make sure that I epoxy both sides of the wooden blocks to the disc, so we have a good friction connection between this axle and the disc. Then what we'll do is I got these metal pieces of steel. Just flip them over here. I painted them so they're a little sticky. Just gotta let them dry. They're getting to be a little bit better, but basically what'll happen is these metal discs or these metal plates will stick in like that, and they'll support a magnet, a 2x2 magnet, and then we got this set up so that the 2x2 magnet will sit about here, and then we'll have a set of brushes on the inside and a set of brushes on the outside, and then we'll spin it and see what happens. And I think I already described in the last video how I'm going to wire it up, so I don't need to go over that again. And then we'll see if we can make this Faraday disc, if it even is going to work at all, and go from there. But I glued the pieces together, all the bottom ones on there, so you can see the glue really stick gooping out there on the bottom. It's a pretty smooth surface, so I don't know if it's going to really stick or not. Maybe I should have roughed it up, but we're going to try and see if it'll hold. It is going to be bolted, so just set this to sit back in there. It is going to be bolted, so there should be pretty good friction on the disc, because the brushes I got, I was going to buy brushes, but it's pretty easy to spend 150 bucks on brushes, and I don't even know if this is going to work. So I got these from an old alternator. So these will be one set. This will go on the outside, that'll go on the inside, and then I got brushes from all these other motors, which I'm just going to take apart. Or these are all switches that I made. They originally from motors, and then I turned them into switches, and then never used them. So, but it was fun building them anyway. And I can take the brushes out of there and set up a way to mount them so that we can get a signal through the Faraday disc. The good thing about this type of a Faraday disc is that if we can get it high enough voltage that we get some kind of results out of it, then we can bring another magnet in over here and do the same thing, and another magnet here and another magnet here, and we can set it up with 4 magnets on each one and just draw power out of it till the cows come home. Because what if Michael Faraday just missed the RCF factor in the disc to extract the real power, the real energy, prime mover force. All the electricity is a vehicle to move the immense force of RCF off the disc. We're going to find out, and this should be fun to do this. But these discs are like 60 bucks each. It's a copper, because the whole sheet ended up costing me like 250 bucks for the whole sheet. But that's all the money I can spend on it. I mean, that's even spending too much. Hello, it's April the 26th, 2019. What we had to do is change out these washers on the device, because as you can see, I'll show you here, these washers are different thicknesses that I had on there. So these ones here, that one's a little bit thinner, and some of them are really thick. So it was throwing off. You can see this one here is really thick. You can see that the difference between those two is quite a bit. Wow, almost 35 thousandths of a difference. So now we got these washers, which are all pretty much the same thickness. And we're going to install this device as a sort of like a test and see how it sits in here. This is the magnet setup. So the copper's going to fit in those gaps, and then we're going to see how it goes. Okay, so you can see now how the copper discs sit between the magnets, right? And of course this is going to be supported on a bearing system. Hello, it's April the 28th, 2019. So you can see here we got the project's really coming together. We got these mounts on here for the bearings, and of course the system does roll pretty good between those magnets. And I had to extend the shaft here a little bit because we're short on it, so because I want to put a pulley, a 12-inch pulley on this side here so we don't spin it too fast. I don't know, 350 RPM is good enough for this to rotate, and we'll go from there. But I had a new theory where with all the devices that we built, I mean the T-Gen and the ZZ-Gen and of course all of them, and we haven't been able to get any results out of them. And then it dawned on me yesterday as I was watching the news, just after the news there, that with this device, the Faraday disc, and putting them in series like we're planning on, or we may do a parallel configuration as well. What if we're able to extract gravity out of the device? Wouldn't that be awesome, right? Because then a lot of people have been saying that centrifugal force isn't a real force. Well, it was real enough to throw me off the merry-go-round when I was 3 years old. It feels pretty real to me, and it's real enough in a washing machine when my clothes come out almost dry. So I think it's a real enough force, and I think it's worthy to be captured. But to quiet all those critics, the idea that really came to me was if we can extract gravity out of here, because gravity's pulling straight down, right? From the earth, it's pulling straight down. So as this is rotating, right, we're going to have an RCF factor, and it's going to be pulling straight down, and we're going to take our signal or source from the very bottom end of these discs, right? So what if there's a way to combine gravity with electromagnetic force? I mean, a lot of the physics field papers that have been able to acquire just at random have shown a lot of electromagnetic and gravity coupling, etc. Right? So if it's possible to mix gravity with electromagnetic force, and then the gravity comes out on our signal, and then we're able to build a shield, a gravity shield, and then with that shield we're able to, say, shield this device from gravity. Because maybe the real kicker is with all these designs, gravity has been stripping away all the RCF that's on them, right? So the first things first, we'll get that built. We'll get the Faraday disc built. We'll do some tests on it, and wouldn't that just be the kicker, right? If we needed our devices to be shielded before they would even work. So that's the way I'm kind of going right now with everything, and we'll see how that works out. But we won't know until we get this device here up and running and testing and actually working, right? It's going to be a very low voltage device, but we could run it through our shield matrix that we have built and see if it would even work at all. Because if we can shield gravity, I mean, that's huge, right? I mean, even if the RCF still doesn't work, to be able to shield it would still open up a whole area in physics that there's actually a machine that can do it, right? And what if Michael Faraday just missed it just by that much, right? Because it was sitting there. He might not have been thinking about gravity. He might not have been thinking about RCF because he was pioneering the whole electricity thing, and that might have been distracting him from it altogether. Anyways, that's it for April the 28th, 2019. Till next time. Bye-bye. and we're going to see if we can add the voltage from each one of these cells and still be able to withdraw some kind of a signal out of it, right? I'm hoping to extract gravity this time, because in a lot of the physics field theory papers that I was able to discover online, there is quite a few of them that talk about gravity and electromagnetism and combining those two. So if everybody thinks I'm crazy for trying to combine centrifugal force and electromagnetic force, then maybe this gives us some kind of a footing to combine gravity, because it is at the lowest point of the plane of these discs, and it would just be complementary, because gravity at the top here is going to be shielded somewhat by the centrifugal force. As it's rotating, the centrifugal force will be pushing against the gravity, and that would not be good. But if we have it at the bottom, then it's complementary, because then we have centrifugal force pushing down and gravity flowing naturally through the device as well. I won't know that until I continue with testing and get it all put together in the first place. But it is coming along, and it sure is a lot of fun to do this. And I got to build one more set of brushes, and then we'll install a drive motor. I'm going to take the drive motor off of the T-Gen. This is the T-Gen here, yeah. You can see I got this drive motor right here, and it's got a nice little bracket on it already. So I'll just remove these two screws out of there, and then that bracket should be able to bolt right into here. So it shouldn't be too bad. I just find a way to bolt it in, maybe about here somehow, and maybe put some spacers or whatever between this block and screw it in. But it should work out pretty good. And it's a 12-volt motor, so we'll be able to power it with our DC power supply. And it'd be interesting to see what kind of results we get out of it. I'm curious to see if I'm going to get even 1 volt out of each one of these discs. That'd be awesome if I do. Anyways, that's it for now, and we'll chat with you later. Bye-bye. Hello, we're back working on this again. So you can see we got the 4 set of brushes in there. They're just sitting pretty good. Some of the heights of the brushes are concern me a little bit, because they seem to track a little bit to the outer part of the disc. So you can see this one here. I don't know if you can see that mark on there, but it's kind of really close to the edge. Same with this one, and then these ones here are tracking a little bit closer in. So what I might end up doing, if it's going to be a problem, is I'm going to release these nuts down here and actually raise it up to get that tracking a little bit closer to the inside. But I think it should be okay. We'll worry about that if it becomes a problem, but it's pretty darn close to the edge. Get it hooked up to the motor. I'm going to mount that motor on there right now, and then we'll get it turned up and see what it can actually do. It'll be interesting to see what it can do. I'd like to hook it up to a coil and just see if we're pulling any gravity out of this device or not. That'd be awesome if we are. Be a real game changer, that's for sure. Well, it's what we need though. We need that though, because this fossil fuels and nuclear and wind and solar and all that is just not good. We need another option. Anyways, I'll keep working on it. Till later. Bye bye. So at least we were right in assuming that these would be able to step up. I'm just going to hold the probe here for a voltmeter, and you can see that the first stage gives us 6 millivolts, and then the second stage gives us 13, well, almost 13 millivolts, and then the next stage gives us 19 millivolts, and the fourth stage gives us 26 millivolts. So at least we can see that that it is adding the voltage between each one. So that was basically what I wanted to do with this, was to prove that that was possible. At least we know that the polarities are of course congruent, and we know that if there's any gravity in this thing, we're going to hook it up to our gravity shield device here right away and see, even though it's such low voltage, see if it's going to produce anything at all. And I was able to get a device sticker on this device and get my RPM meter, and you can see that just gotta hold it the right way. You can see that it's going 117 RPM, but this motor is getting pretty hot, so it's almost ready to burn up. She's getting pretty warm. So okay, so what we've done is we've installed this quarter horse motor on it, and it's going to run off of 110 volts, and it seems to be clipping along pretty good. So before we were at about 120 RPM with the 12 volt, and you can see here that we're about, if I can get it the light, set it up so that I can see it. So about 220 RPM. 220 RPM. So we almost doubled the RPM, and by doubling the RPM, we have doubled the voltage going across each one of these cells, because before it was about 6.5 and now it's 12 for each one. If we go across the main, before it was 27, now it's 47. So we almost doubled the RPM by 100, and we went up by a factor of about the same. So it looks like that's linear, right? Because we're about 85% increase in RPM and an 85% increase in voltage. So that's basically straight across the board, right? And this little motor here is going to work out just fine to rotate this device. But I will hook up our shield. Whoops, dropped the wire off of that. I'm going to have to solder that wire on there and see if we get any power coming out of it at all. But I don't think we're going to get anything out of it. I think that all my theories have been proved wrong with this device. But I'm going to continue on testing and see what we get for a signal, and that's all we can do. Anyways, till next time. Bye-bye. Hello, it's me, the 6th, 2019. So we did one last test on this device. Basically what we did is hooked up all these discs in parallel and hooked them up to this coil, and of course there was no artificial gravity coming out of it, or no RCF transfer whatsoever. So this is a fun experiment to work on and build, and an expensive one too. Lots of money for this copper, but at least now we know, right? And it was a fun project to work on. So I'm just going to shelve it off to the side for now, and I'm going to work on another project. Anyways, that's it for now, and you have a good day. Bye bye.